Today we're looking at some sample problems on section 10-2, and those begin on page 510 in our textbook. So we'll start with number 3. It's entitled High Blood Pressure. It says some studies have shown that there is a correlation between consumption of salt and blood pressure. As more salt is consumed, blood pressure tends to rise. A reporter reads one of these studies and writes the headline, "Increased salt consumption causes blood pressure to rise." Is the headline justified? If not, help the reporter by rewriting the headline so that it is correct. Alright, the problem with a correlation, just because we have a correlation does not mean we have causation. So the problem with his headline is that he's saying that increased salt consumption causes blood pressure to rise. So I would want to rewrite his title to his headline as increased salt consumption associated with blood pressure rise, or increased salt consumption correlated to blood pressure rise. So you need to somehow change causes because that's not necessarily true. We just know that they go up together. So causes should be replaced with associated or associated with or correlated to. So the key to remember here is that correlation does not mean causation. Okay, let's look at number 4. In number 4, it says, in the test of the Weight Watchers weight loss program, weights of 40 subjects are recorded before and after the program. Assume that before-after weights results in R equal to 0.876. Is there sufficient evidence to support a claim of linear correlation between before and after weights? So let's look at that. We had 40 subjects, so we need to go to our table A6. And the critical value from the table, we are using alpha equal to 0.05. Critical value is 0.312. So there is sufficient evidence to support the correlation. Does the value of R indicate that the program is effective in reducing weight loss, or why not? Well, the problem is, although there is a correlation to the before and after weight, it could be a correlation if the weight is the same. It could be a correlation if they gain weight, if everybody on the diet gained weight. So just because there's a correlation doesn't mean that the weight loss program was effective in producing weight loss. So we have to, there again, be careful about that. So yes is the first question, it's correlated, and no, it does not mean that the program is effective in reducing weight. It could be maintaining the weight, or it could be just gaining weight. So we don't know which one. All right, number 5. For 40 eruptions of the Old Faithful geyser in Yellowstone National Park, duration times in seconds were recorded along with the time intervals in minutes to the next eruption. The paired durations and interval times were then used to obtain the results shown in the accompanying stat display. So we have R is 0.6869123. The critical value we want to compare it to is 0.312. The absolute value of R we want to compare to 0.312. Is there sufficient evidence to support the claim that there is a linear correlation between the durations of the eruptions and the time interval to the next eruption? So as we look at this one, again we see our R is greater than the absolute value of R is greater than the 0.312. So we do have sufficient evidence to say there is a correlation. Our next question Let's see, I guess that's all they ask us to do. And it's because the absolute value of 0.687 is greater than our critical value 0.312. Okay, now we're looking at number 8, cereal killers, and they've spelled cereal with the kind we eat. The amount of sugar, grams of sugar per gram of cereal, and calories per gram of cereal were recorded for a sample of 16 different cereals. TI 8384 Plus calculator results are shown here. Is there sufficient evidence to support the claim that there is a linear correlation between sugar and calories in a gram of cereal? Explain. Okay, so as we look at this, R is 0.765 rather, 0.765. So if we flip back, we were looking at 16 different cereals. So the table value, the critical value is 0.497. So we have, answer is yes, because the absolute value of 0.765 is greater than the critical value in the table, which was 0.497. So that's the reason for our yes. And they want us to explain, and there again, what we see is from the comparison of our R to the value, the critical value in the table. Alright, so our next group, we're supposed to do construct a scatter plot, and the title of this group is Importance of Graphing. And so the exercises 9 and 10 provide two data sets from graphs and statistical analysis. We're to construct a scatter plot, find the value of the linear correlation coefficient R, and then determine whether there is sufficient evidence to support the claim of a linear correlation between the two variables, and identify the feature of the data that would be missed if part B was completed without constructing the scatter plot. Okay, so we're going to do number 9, and for this we'll need our calculators. So I'm going to go to my calculator, and I need to go to Stat and Edit. I want to enter X in column 1, L1, and Y in column 2. So I'm going to, okay, 10, 8, 13, 9, 11, 14, 6, 4, 6, and a 4, 12, 7, 5, 12, 7, 5. Okay, now I need to go over to the next column, and 9.14, 8.14, 8.74, 8.77, 9.26, 8.10, 6.13, 3.10, 9.13, 7.26, and 4.74. Okay, so we have our points in. So what they want us to do is do a scatter plot. So I'm going to do second and y equals, get step plots. I have plot 1 on, so I'm going to enter. Alright, I want to come down, and on is correct. So, whoops, not too fast. On is correct. Type is, I want the scatter plot, which is the very first one there. So let's enter. And L1 and L2 are where my columns are. I can choose any of these. Let's see. Let's choose the plus. Whoops. I'm still up there. Enter. Okay. Let me go over and I'm going to choose the plus. Okay. Alright, so now what I want to do is go to Zoom. And I'm going to come down to Zoom Stat, which I believe is number 9, but I'm going to double check it. It was number 9. Alright, so what I notice here is I have something that looks like the part of a parabola. So it would be quadratic. It looks like it would definitely have a quadratic correlation. Alright, let's see what happens when we find R. So I'm going to go to Stat. And whoops, I want to go to Calc. And I want to choose linear regression at number 4. And I want to enter L1, comma, L2. Okay, my R is 0.816. And how many data or pairs do I have? 1, 2, 3, 4, 5, 6, 7, 9, 10, 11. So if I look at my table, turning back to my table A6, 0.602, so certainly our R, or the absolute value of R, is greater. So we do have a linear correlation. And looking back at the graph, you can see that a line would very closely, could very easily come through that graph to produce that linear correlation. But what would we have missed if we did not look at the graph? Well, we would miss the fact that the graph shows it's distinctly not a line. Even though there's linear correlation, it's more strongly a quadratic correlation because of the shape of the parabola that we see there. And the graph would show us that, whereas the value of R just tells us there's a linear correlation in this case. So it's not really giving us the best evidence or the best information about this particular set of data values. Okay, now we're going to move on to number 14. This is on page 513. We have PSAT and SAT scores, and so they've been taken from prospective college applicants. And what we're to do, we're to find the value of the linear correlation coefficient R and use table A6 under alpha equals 0.05 to determine whether there is sufficient evidence to support the claim of linear correlation between the two variables. Okay, so as we look at number 14, we want to go to our calculator.